So we're going to open up Fusion 360 and we're going to make a new sketch. And I'll choose the front plane to do that. First, we're going to draw a circle, and this is going to be the diameter of the threads that we need. In this instance, it's going to be 3/4 of an inch or 19.05 millimeters. Once we've done that, we can finish the sketch, use the extrude tool to make our circle into a cylinder, and we are going to extrude that 9.5 millimeters. That is roughly the depth of the threads in the cap that I'm using. Next, we're going to draw a new sketch on this surface, and here we're going to draw 3 circles. They're all going to be concentric to this cylinder. We'll just draw them out first, and then we will dimension them. So the first one is going to be 6 millimeters, which is the size of the potentiometer shaft. The next one is going to be at 8.5 millimeters. And the third one will be at 16.55 millimeters. And these circles are basically just providing sort of a shell for sort of a structure. And once we've done that, we want to make sure that it's constrained properly. So we're just going to make sure that all these circles, okay, it looks like they're already concentric to each other. If the lines show up as blue, then that means that they're not fully constrained, and when you click on them, they will be able to move freely. Next thing we're going to do is going to make this sort of supportive cross shape that will hold this interior circle and also provide an area that you can grab onto when you're trying to unscrew and screw into the cap. So we're going to use the line tool to make 2 vertical lines, and we're going to draw these from the second circle to the third circle. We will dimension these so that they are 0.625 millimeters away from the center. If you want, you can, for the second dimension, you can just click the first one and that'll make it parametric. So now, with this being parametric, if you change the dimension on the left, it will automatically change the dimension on the right that we just made. Next, what we're going to do is we're going to use the circular pattern tool, and we're going to select these 2 lines we just created, click center point, and click the center of our circles. Make sure the distribution's full, and change the quantity to 4. So this will sort of mirror the 2 lines around the circle. Because we don't need these lines, we're going to use the trim tool, trim these little lines that connect the inner circle and the outer circle. Just makes it a little easier to cut when we get to the next step. After we finish the sketch, we're going to go back to the extrude tool, and we're going to select extent type, all, operation, cut, and we're going to select the center hole where the potentiometer is going to go, and then these 4 other shapes that kind of look like Simon buttons. And then we also need to hit the flip button, because right now it's thinking we want to go in this direction, but we want to cut into the shape. See, now we're cutting into the shape. So now we have this funky looking shape. It's kind of like a crosshair, cross pattern, and we need to add threads to it. The threads will allow us to screw it into the cap. So we'll go up to create thread. We'll select the side of our cylinder, and then I know that what I'm working with is ANSI unified screw threads, so I'm going to select that. It already is pre-selected the size because my cylinder is 3/4 of an inch, or that equivalent in millimeters. And now we can select the thread type, and the thread for my cap is 3/4 16. So that'd be 16 threads per inch. I'm going to select that, And then you also want to select the class. And the class, this is basically the tolerance, with 1A being the loosest tolerance. So we want to keep that because it'll make it a little easier while we're 3D printing it. And then lastly, make sure that you click modeled, because right now it's just showing an image of threads rather than actually cutting the threads into the cylinder. Because we're 3D printing, we actually need to cut the threads. Hit OK. And now our part is complete. To export it, we can go to File, 3D Print, and we're going to keep it on STL binary. Select the part, keep it at millimeter, keep it at medium. I'm not going to send it to the 3D print utility. I'm going to hit OK, and then it's going to ask you where you want to save it. I will save it right here, and then you can use that in your slicer or your 3D printing software. Thanks for watching, and hope you learned something.